Today is very exciting. You are going to learn how to sketch the graphs of sine and cosine. So, the unit circle. We've been working with the fact that the y-coordinate of the unit circle represents values of sine. So what I want you to know is, as this progresses, so this, oh, didn't mean to do that. Okay. This point right here on the unit circle is going to be turning around the circle. And we're going to be focused on the y value that we see here in red. It is going to be matched with the y value that is creating the sine graph over here. So what you need to know is this is the y-axis. This is the x-axis. So we're looking at starting with angle 0. Are you ready? Because this is super exciting. Okay, I was hoping for a little more excitement, but I didn't expect. Watch, watch, watch. You ready? You ready? Remember that sine starts off at 0 when you're at angle 0. And then the y-coordinate grows. And what you want to understand is the angle of turn from 0 to 90 degrees. We are taking that angular motion and transforming it into a linear motion. So instead of turning, as we see with this arc, we are instead going along the x-axis as x being the input for I'm at this angle now, I'm at this angle now, and right now I'm at 90 degrees. Now, the value of the y-coordinate is 1, and that's its highest. And then after 90 degrees, it continues and goes down to 0. But then what happens after 90 degrees? It goes negative. So now I'm watching it go negative. Those negative y values go down to -1. And then the y values come back up to 0. And then the circle starts all over again. And it will keep making this motion over and over again. So I have a graph waiting for you to show you the whole sine graph. Now, know that I have this set up in degree mode. And let me close that. Know that you actually have to, if you go into Desmos and you start typing in sine and cosine, it's going to be based on radians, which we're going to do after our first test. But in order to convert it to degrees, you have to change it right here. And I had to dramatically change the viewing window so that my x-axis, basically, if you look at it, about 45 degrees is 1 unit. So 45 units for every 1 unit, you have to drastically change the x-axis where it exists between and the y-axis. So if that wheel were to turn over and over and over again and keep going round and round, we would just create a giant sine wave that goes forever in both directions. Okay. So do realize if we choose to go the negative direction, which I can't show on here because this is specifically designated to just go from 0 to 360. But if I were to head the negative direction and go this way, that would create this graph along here moving in the negative direction. And so this is a graph that goes both directions from negative infinity to positive infinity. And let me go back and find this. So I'm going to post this particular document into the classwork, but I didn't post it yet because I didn't want you thinking that it was part of the classwork. This is just if you want to look at it one step at a time with some explanation, that's what I have here. And also, if you want to um, play with the Desmos, I guess you have to do like control click. Was that it? You guys know how to do this stuff. Anyway, there's a link to it. So that's the sine graph. Now, in your classwork, we are going to sketch one cycle of this sine wave. The first thing I want you to do, though, is plot the certain points. First of all, when our angle is 0, our sine value is 0. So plot a point through the origin. When we get to 90 degrees, our sine peaks at a value of 1. Then it comes back down, and by the time we get to 180, it's back to 0 again. Then it goes negative, and by 270, it reaches its lowest point of -1. And then in the next quarter cycle, it comes back up to 0 to be prepared to start it all over again. What I recommend you do is draw an arch between the point 00 and the point 180. So you're going to draw this nice little arch like this. Then for the part that is underneath the graph, draw an arch. It's identical to that arch, but upside down. The part that goes from 0 to 180 should look like a bowl that has been turned upside down and your cereal has just fallen. Whereas from 180 to 360, it should look like a nice bowl ready to eat cereal. So I'm also going to draw a little bit farther. I'm going to go backward. If I go back 90 degrees, I will go into the negative values down to -90. And I'm going to show you what I have drawn on the answers. Very important, know that the main cycle is 0 degrees to 360 degrees, but that the graph goes on and on and on and on and on. When I ask you to graph one cycle of a function, I'm referring to what originally begins in 0 to 360. Okay, now, was that kind of cool? Okay, well, it's time for cosine. Did they catch? Oh. I don't know. I left it to them. Yeah. Cosine actually looks very similar. In fact, the graphs are identical. They're just shifts of each other.
So it's kind of like a formula. So like each
Uh,
like sine or cosine thing is different.
it's more that they start in a different place. They're not actually that different. It's just they start in a different position. Sine starts, if you're looking at 0 degrees, it starts in the middle, whereas cosine starts at the top. So cosine is actually going to start here, and it's going to look exactly the same. It's just going to look like a shift over. And Yeah.
Oh wait, on the actual classwork, it goes to -90. So when it's on that set of data,
Oh,
it dips down to -90, correct? Because
yes. Yeah. Yeah. I didn't get that in this particular drawing, but yeah, it goes down and then it would be then coming back up. And so something like that ish. Uh, now, if you think about it, from what I just said, you may not see a need to have two of these. And you could say maybe you don't need to have the two graphs, but they can become convenient when it has to do with, are you starting at the center or are you starting at an extreme point? Because you're going to find out soon enough that horizontally shifting these things is not pleasant. And so it just creates two options. And I'm going to now show you cosine. Are you ready? Are you ready? So what's different with cosine is this time, notice that the red is horizontal on the unit circle. And let me show you the difference. On this circle, the vertical was the red length, and it was matching this red vertical distance. Sine is easier to see because you're transferring something that is vertical to something else that is vertical. Cosine is harder to see because you have to transfer something that is horizontal to something that is vertical. So this right here, this red x length, that is the same distance as this vertical distance. And that makes it a little bit more awkward. So as this plays along, you're following this point on the circle, but the focus is the x coordinate, this red length. As it moves along, that red distance is going from 1 to 0. And then right after you pass 90 degrees, it goes into a negative x coordinate. And so this negative distance is this negative distance. And we keep following it. And eventually x hits -1. And then it's negative and starts its way back up. Finally, at 270, the x coordinate is 0 again. And then the unit circle has its x coordinate grow back to a value of 1 as it finishes the cycle. And so that is your graph of cosine. And now, yes. Yes, I am. Thank you, because there have been days I have not. All right, cosine, here we go. Cosine at 0 degrees starts at a value of 1. As the unit circle watches an angle turn from 0 to 90 degrees, cosine shrinks down to 0. Then cosine goes into negative values and reaches its lowest point at 180 degrees and a lowest point of -1. Then it comes back up. At 270, it's back to the center. And at 360, it's finished its cycle all the way up to the top again. Now, listen carefully about graphing this because I really don't want this to look like this. So watch. I'm going to graph from the center point. By center, I mean the vertical center. So y value 0, y value 0. I am going to draw a bowl of cereal that is in your hand ready to eat underneath the x-axis. Above the x-axis, you are spilling your serial. So this arch needs to go the other direction. And again, spilling your serial, this arch needs to go the other direction. And I could continue the graph over to -90, and I can see the full serial spilling. And then it just continues. So I don't want this piece to look like this. It needs to be curved relatively decent. I really, oh my gosh, you guys should have had those not Desmos, the Chromebooks. You should have had those Chromebooks by now. That would have made this a lot easier. I don't know when they're coming. You really, really could use them right now to draw these graphs. But you at least have pen and paper. Yeah?
So cos is just the alternate graph of sin.
It's a shifted graph. And let me show you the two of them together. And you can see that they are the same graph, just shifted. Okay. Are you ready to start graphing? With the amount of work that we put in earlier in this year with transformations, you're far more ready for this than if we hadn't done that. Do you remember several chapters back, we talked about the transformations with stretching both vertically and horizontally? This is going to be very, very, very important now. But I will say that you might already feel comfortable with it enough that you maybe don't need to write all this down, but let's go through it. I want to just warn you about a couple of things. These are the formulas that you will see for all the transformations. A is a multiplication outside the function, so it's a vertical stretch. And do you remember that the vertical stretch is always, you do exactly what it says to the y coordinates. If it says times 2, you stretch it times 2. All the y values are multiplied by 2. Letter B is representing whatever number x is multiplied by inside the function. Do you remember that instead of multiplying by b, you actually have to take the x values you have and divide them by b? Horizontal transformations affect the graph with the opposite operation. If b is 2, you're going to actually squish the graph in half. Now, you're familiar with the horizontal and vertical translations. Now, I've got to say, I have it written right here. I want you to understand that the standard formulas you're going to read are written as minus c to help emphasize that if you see something like x minus 2, you're going right to. But they did not come up with a nice thing with the multiplication there. So honestly, I feel like it ends up being a little bit confusing as to why there's a subtraction there. I personally would prefer to have them written this way and just express that operations inside, you simply do the opposite operation. You see plus, you're going to do minus. You see minus, you're going to do plus. You see multiply, you're going to divide. You see division, you're going to multiply. That is not the way the standard things are written, though, so that's how they write them. And I had to go through an entire explanation of why they have a minus c, but they didn't do a divided by b. They could have chosen to write this as divided by b right here. And I feel like if that had been done, it would at least keep things along the same track as far as always thinking about the opposite operation. But anyway, so let me go to the answers. So I want to emphasize inside operations are the letters B and C that you see here. B and C. You're going to take your original x coordinates of the parent graph and you're going to do the opposite operation that you see in front of you. And we'll do examples to help you with that. And just to emphasize, that means that if you see multiplication by b, you're going to take the original x coordinates and you are going to divide them by b. If you see division by some number b, you're going to multiply the original x coordinates by b.
So why did they make it so confusing instead of just making it pretty simple?
I don't know. That's why I went through this long explanation right here, because I feel like it would have been more consistent if they had just left it this way and just said opposite operations for inside, same operations for outside. Would have been a lot easier. But traditional textbooks got made the way they got made, and when they were bringing in Common Core, I was hoping they would make some of these certain changes that I felt need to be made weren't the things that they changed. Anyway, it's okay. Everyone, that's the problem though. You get different math educators and you have different opinions on how things should be processed. Anyway. Also, if you see addition by C, you are going to actually subtract C from the original x coordinates. If you see subtraction, you're going to add. Then operations that are outside the function are A and D. You will change the y coordinates using the given operation. So I want to emphasize the x coordinates are changed with the opposite operation you see. 1 second. Water. Sorry. Don't worry, that's not COVID. It's not even a cold. It's just, never mind. Okay. So, emphasizing x coordinates get opposite operations. Y coordinates use the given operation that you see. And notice the inside versus outside.
I am so utterly lost in this entire thing. Everything is
Okay.
switching and turning.
we will go through examples. Just be a little bit patient. Right now, I'm trying to lay out the groundwork. We haven't even hit the examples yet.
Wait, can you go back to the addition by C?
Mhm.
Originally?
Yes. Yeah. Okay. Yeah. Also, if I go a little bit too fast, you have these attached in Google Classroom, these answers. It may feel a little bit tiresome to write out, but I want to make sure to emphasize, if you get the key ideas, it's going to be smooth sailing. When the operations are outside, then when you see multiplication by A, you will multiply the y coordinates by A. If you see division by A, you will divide the y coordinates by A, the parent y coordinates. If you see addition by D, you're going to add D to the y's. Subtraction by D, you're going to subtract D to the y's. And are you about ready? Yeah. Oh, tangent's coming. You're about ready to fall asleep. I'm so sorry. Listen, tangent, you are not going to see that until after the first test. We're going to focus on sine and cosine for a while. Okay. Now, the directions for the graphing problems. Come on. There we go. You're going to sketch first one cycle of the parent function, and then you're going to sketch the full graph of the parent function and the given function. I thought I'd put, yes, and the given. So one cycle of the parent, one cycle of the transformation that is given to you. Then you're going to draw both of them across the grid. We're going to do this together. Oops, those are the answers. We're going to do this together. First thing you're going to do is sketch the graph of sine. And let me remember what color I used so I can just stick to, I used blue. Okay. So one cycle of a sine graph. This is what we just did before. I'm going to put 0, 0, 91, 180, 0, 270 is -1, and 360 takes us back to 0. Plot those 5 points. Above the x-axis, draw a spilled cereal bowl. Under the x-axis, draw a cereal bowl full of delicious cereal. Now, prior to this time, I haven't done, I've been doing things very slowly in stages with you. And now I'm going to want you to start doing more at once. I'm going to start over here with, I have a 2 multiplied outside the function. I'm going to start there and treat this as an intermediate graph. You can draw more than just the parent and the final graph if you want. In fact, I do that a lot on the homework explanations. So I'm going to first look at what happens when I stretch it by multiplying the y values by 2. That means the y value that was 1 is now 2. The y value that was -1 is now 2. The y values that were 0 will not move. And you can see the stretch. and now a spilled tall cereal bowl, and a very deep cereal bowl with lots of good, yummy stuff. So I want to emphasize that this green graph is y equals 2 sine x. I haven't done the multiplication by 3 yet. The blue is the parent graph of y equals sine x. And now I'm going to draw this one cycle of this particular function in red. I see that x is multiplying by 3. That means I'm going to take all of the x coordinates. I've got a 0, 90, 180, 270, 360. I'm taking all of those x coordinates and I'm looking at the green graph. Sorry, colorblind. In fact, for you that are colorblind, let me erase the parent graph so that you can see better where we are at. Okay, now the x coordinates, we're going to take every x coordinate and divide by 3. Let's start with 90. 90 divided by 3 is what number? 30? And notice I'm keeping the y values where they are at. I've got to say that if I take 0 and divide it by 3, it will still be 0. Now, x equals 180. What is 180 divided by 3? 60. And 60 is only right here. So where it comes back to the x-axis, that happens very, very quickly. What I can do right now is I can draw for you what happened to the top half. The top half went
The noises of true fear is bad.
excellent. Now I have the other half. And if you see where this is going, you can really just take what you just drew and redraw it, but underneath, going the other direction. But let's go slowly for it now. What is 270 divided by 3?
90.
Yes, it is. So that means that this point right here, we're going to keep the y value of -2, but the x coordinate is being squished over to 90. And then finally, 360 divided by 3.
120.
Yep, you got it. And 120 is going to be this spot right here that is 1/3 of the way through. And now I'm going to draw the little bowl of cereal. And I've got one cycle. So what is drawn in red is the final graph, only one cycle of it. Now I'm going to draw, actually, let me show you the answers because the answers are easier to read. I have it set up to give this to you very slowly in the answer guide. So you can see here, I'm starting with sine. I multiply the y values by 2. And then I'm dividing those x values by 3. And you can see the progress in this last piece. And then for the full graphs, they can get a little tiresome, but yeah. Understand that the full graphs isn't so much me wanting you to burn your hand out and have carpal tunnel. Well, I'm exaggerating, but I want you to see the full scope of it. You can feel free to draw that quickly yourself. Just real quick, all you have to draw are the blue and the red, which for those of you who don't know what I mean, this one is the original. And then I think you can tell the difference with the red. Yes, yes. And it sounds like that. What may actually be slightly more valuable is for you to see with a graphing calculator or on a Desmos program to see the full scope of the fact that it keeps doing this over and over and over again. What I don't want is for you to do only one cycle so many times or only 2 cycles where you don't fully grasp the fact that this literally goes forever both directions. Okay. Now, let's go on to the next one, whether or not you've finished like the full graph. Again, don't feel like you need to draw the most amazing thing. In fact, let me show you what I would accept. Are you ready? You can plot these points. These are going to help you. Do you see what I'm doing? Just draw those. This is the parent graph. And then you can feel free to quickly just go, oh, no, that's terrible. Okay, decent. There, good enough. Then you want to get the pattern going for the final graph, which you see in red here. So what you can do is draw one cycle. And let's see, a third of the way through, a third of the way through, all the way, and then a third through. I realize it's very, very tedious to draw more than that. Feel free to just kind of quickly show me that you get 8s going. Honestly, I know that it's almost a bit of a pain for you to draw it perfectly. Just get kind of the idea going, and I'm fine with that. But I want you to look at what it actually does look like. I will have that in the answers. And it's really important for you to just look and see the full, or, you know, a good giant chunk of it. Why does the graph look like it goes through 60 degrees? Oh, you mean has an x-intercept? It does. If I were to put a little bit more on here, this is 30, 60, 90, plus another 30, and then it would keep going and just keep adding 30 over and over again. So it goes through 60, and then it goes through 120, and then it goes through 180, and then there's a pattern to that. Do you feel good with this problem? Ready for the next one? Okay, I will take the non-response as ready for the next one. We're going to start by looking at the graph of the parent sine function. So here we go. Sine starts at the center. At 90 degrees, it goes up to 1. At 180, it's back to 0. At 270, down to -1. At 360, it's back to the center. That's one cycle of the parent graph. For this problem, I have only addition, subtraction involved. Outside the function, we see a +1. Outside the function affects y, does exactly the operation that it says. So every one of these y coordinates is going to move up 1 unit along with the rest of the graph. You probably don't want to draw the arrows that I just drew, but I was trying to emphasize the movement of everybody up. Then, if you look at x, it says -45. You're not going to subtract 45, you're going to add 45 to the x's. So this point that was at 0, 0 moved up 1, and now it's moving right 45, which is halfway to 90. The point that started at 91 moved up 1 unit and is moving right 45 degrees. The point that was at 180 degrees 0 moves up 1, right 45 degrees. The point that was 270 -1 moved up 1 unit, right 45 degrees. And then finally the last one, up 1, right 45 degrees. When the only thing you're doing is addition, subtraction, the shape will stay as is, and it's just going to move to another position. Now for the full graphs, again, I don't want you to feel like you've got to draw a perfect graph. I just want you to show that you get the idea of the nature of these graphs, that it goes boom, ba-doom, boom, ba-doom, bada-boom, bada-boom, bada-boom. See how I was relatively sloppy? I'm okay with a little bit of sloppy right here because it's a bit much in graphing. Then I can see this other one starting a cycle here. And what I might want to do is draw some points to help me see where I should be going. And then do a relatively decent job just kind of continuing that. And I'm not drawing it perfect at all. But I want you to see what it should look like. And when you look at the answers, I've got start here, shift it up 1, and then from there, shift it right 45 degrees. And here I'm showing all 3 graphs. I only asked you in the directions to draw 2. If you want to draw 3, you can. But if you want to do both, if we can do the one cycle, then what's the point of the full? Yeah, I know. That's why I said you can be a little bit sloppy with it. I want to make sure that you see the full and that you get that it does keep going. But do you get what I mean by feel free to be sloppy on the full? I just want you to show that you get the idea. And honestly, one of the biggest things is I want you to look at what it really does look like over a longer period of time than just one cycle. Okay, are you ready? Ooh, I have to say this. Well, it won't be in time for you, but the next crew who gets the Chromebooks, with this, I might tell them to take a snapshot of a Desmos. But you guys don't have that ability because you don't have those. So let me say, if you actually do have that ability, feel free. Okay, next problem. This time it's a cosine, and I'm going to start with the parent cosine graph. The parent cosine graph at 0 degrees starts at its highest point, moves down to the center y value, and then moves all the way down to -1, back up to the center value, all the way back up to 1. And then a bowl of cereal spilling, a nice bowl holding, and a spilling. I'm going to start with the y because it's easier to deal with. If I multiply all of these y values by -5, the y value that is 1 is now times -5. 0 times -5 stays 0. -1 times -5 flips up to +5. 0 times -5, and 1 times -5. While I don't expect you to graph the intermediate one, you might find it helpful. The next piece is, take a look at x. That shows x being divided by 2. So what are you actually going to do to the x coordinates? You're going to multiply by 2. And for the sake of the colorblind, I'm going to erase the original parent graph, or erase parts of it to an extent. And now I'm going to look at the x coordinates and multiply by 2. I'm going to start with 90. This point, its x coordinate is 90. 90 times 2, 180. This point right here, this one, its x coordinate is 180. What is 180 times 2? 360. And then I'm going to go back to when x is 0, 0 times 2 is still x coordinate 0. Now this has gotten me halfway through a cycle, so let me show you what we've got so far. Next, over here, my x-coordinate is 270. What is 270 times 2? Or you could just go, hey, that's three sections, 90-degree units. So go another 3. 1, 2, 3. Boom. $270 times 2 gives you 540. And then lastly, this point is 360 for its x-coordinate. 360 times 2 is 720. And I have my final graph. I want to say again, you can do a sloppy job on the full graph. I would prefer that you were able to just look at it and give me a snapshot of what you see. That's what I would, but anyway. The answers go through step 1, intermediate step, and then seeing the final 1 cycle. And then over here, I have graphed the initial parent graph is this one. And all I asked you to do in the problem was to graph this one and the final one. But I thought I'd show you the intermediate because it helps you to see the stages of progression. But I just need to see what I highlighted and then the red graph. And I believe I've got one more example waiting for you. Or I don't. Ha! Who just lucked out? You did. So just go through and do your best quick job of drawing that further out. Okay, let me make sure you're clear about tonight's homework. These first 12 problems are reviewing what we have done so far. And this is what you were wanting a little extra help on, or some of you were. Then the rest of them are just graph 1 cycle, graph a full graph. If you want to take a snapshot, and you can, feel free to. And know that you're trying to get used to drawing sine and cosine. Now, if you want, I can start talking to you about these problems to help you get started. So if I take a unit circle, I'm going to draw a quick unit circle. I've got my x and my y axes. 120 degrees is 30 more than 90 degrees. So 90 degrees stops here. 30 more than that is 120, which stops here. And sine is looking at what is the y coordinate if the terminal side of my angle lands at this point. So I have initial side, terminal side, the angle turned, but I want to know the y coordinate of this point. And if you look at the other angles that you're supposed to be aware of, this one is the highest up of the 3. It's furthest of the 3, so it's root 3 divided by 2, and it's on the positive y-axis. For the cosine of 315, I'm going to erase what I just drew. 315 degrees is 45 degrees shy of 360. Or you might say it's 270 plus 45 degrees. So realize that what this is saying is from an initial side of 0 degrees to a terminal side of 315 degrees. So my turn goes, bing. The question is, what is the cosine of that angle, which would be the same thing as asking what is the x-coordinate of this point on the circle, knowing where the other angles are, knowing that this one is the center of them. Being the center of them, it is the second one away from the origin, and it's on the positive x-axis. The second one over is root 2 over 2. Yes, you can leave. If you need a little bit more help with this and want to get some of your homework done, I can keep going for another 5 minutes.
So wait, just make sure that I'm good for my homework.
Yeah.
So, the line is usually just blank over 2, correct? Unless it's on the other side, which then it's negative blank over 2.
Yeah. Mm-hmm.
All right. I'll see if I can do that next. Thank you.
Okay. If I go over and I take a look at 7 and 8, or for those of you that are still here, would you like me to keep going or go over to the 7 and 8? You can leave. The class is over. 7 and 8. Okay. So this is going the other direction. It's going backward. I'm going to draw a circle. What I find easiest is to remember that sine theta is x. So I'm really just drawing x. I'm sorry, I just said it wrong. Start again. That's terrible that I messed that up. Sine represents y. I want to draw the line y equals negative root 2 over 2. That's a horizontal line. There are 3 special numbers between 0 and negative 1. Down the negative y-axis. And then the root 2 over 2 is the middle of those. If I draw a horizontal line across, it goes through the unit circle in 2 spots. Now, what is ultimately being said is, with this being my initial side, one angle who has a sine value, negative root 2 over 2, has a terminal side that goes through this point that has a y-coordinate of negative root 2 over 2. Additionally, there's another one, and I've got same initial side, but now terminal side over here intersects the unit circle at y-coordinate negative root 2 over 2. So that's representing the angle that goes all the way around this way. And now I need to find what are those 2 angles. These are the center angles that go halfway through the quadrant. If this is 180, then adding 45 degrees to 180 gives me 225. This would be 270 plus another 45, which would give me 315. And so those are the 2 answers for between 0 and 360 for number 7. And I'm going to erase and then do 8. cosine is looking at the x coordinate. I didn't get the two answer part. You mean by getting two different answers? Okay. Okay, good, good. And if you want to stay for a little bit longer, I can do the next one. Tangents are the hardest ones, so I may need to talk about that tomorrow. If the cosine is x, then I'm drawing a line x equals positive. Now, there are three positive numbers for x that are important. This is the third one. And that takes me over here with an understanding that I have these also. So what's happening is you have an initial side. If you go that much, which my drawing is not to scale, that's a 30-degree angle, supposedly. That's one of the answers. The other answer is if the terminal side lands over here, which is 30 degrees shy of being 360. So if I start at my initial and go all the way around to here, that's going to be 330 degrees. And yeah, no problem. And then I'll probably need to go over some more of these tomorrow and help you guys get better at that. But I've got to get over to